Hello and welcome to our webinar today, how to prepare your content for generative and AI search. We are super pumped to be here today. Hope you've had your coffee because we're getting into the technicalities of how search works, how knowledge graphs work, triples and knowledge graphs, entities galore. It's gonna be a party. While we just give everyone one more minute to join in, I'd love it if you just share, say hello in the chat, tell us where you're joining from, and we'll sort of make some calls. I see Team Colorado's here, love it. The UK, Vancouver, oh, that's where I grew up. Jacksonville, oh, New York, your hood, some Canadians, some Texans. We've got the world listening in. We're expecting a really big crowd, and we couldn't be more excited. Oh, we got the Philippines, Pakistan, Kenya. Oh, I have some great memories from my time over in Kenya.
Some great,
Awesome.
great
So
places. This is cool.
I know. Imagine a worldwide audience on a really worldwide topic, right?
Hmm
That's really relevant in sort of what we're going to go through today. Just some logistics. We are going to attempt to answer questions at the end, so we will be reserving 10 to 12 minutes at the end to answer your questions. So feel free to ask those questions in the chat, and our team will be looking to highlight those, and again, we'll look to address them. And then if you need to drop off for any reason, just know that the recording will be sent out in order for you to re-listen, kind of get those knowledge nuggets as they come in. So without further ado, let's go ahead and jump in. So first of all, welcome again. Um, this webinar today is brought to you by Schema App. And Schema App is a scalable knowledge graph solution for enterprise SEO teams. And I'm really excited to be the first time introducing us in this way. People in the world typically know us as a Schema Markup solution, but you're going to learn today that Schema Markup is really that foundation for describing those knowledge graphs. And we work with mid to large organizations to really help their marketing teams develop these knowledge graphs and really get business results. And in this world of AI, those results and how we measure those is changing. Who am I, you might ask? Who's this chatterbox that's welcoming us and hosting us today? Well, my name's Martha Van Berkel, and I am the CEO and co-founder here at Schema App. And I know a thing or two about semantic search, but I am really jazzed to invite and welcome Mike King. Mike, welcome and yourself.
Hey, I'm Mike King. First of all, thanks so much for having me, Martha. I'm excited to be here. And I am the founder and CEO at iPullRank. We are a digital marketing agency. We focus on content strategy, SEO, and generative AI. And I'm also the CMO of a startup, a generative AI startup called AIPRM. And so we're a prompt management solution. We're also a prompt marketplace. We have a bunch of one-click prompts that you can use for ChatGPT and Midjourney and so on to get the output that you're looking for. And we're also moving more into like the conversational interface space. And for anyone that hasn't seen what AIPRM looks like, it lives directly within ChatGPT. And so you can click any of these panels and have a prompt right away. You can create your own prompts. You can select the voice and tone for your prompts. We have a number of different functionalities that ChatGPT should natively have, but we're just like, hey, let's finish this product for you.
Amazing. I love it. Um, and you may be wondering, like, so why Mike and Martha chatting about this? And I really wanted to share that Mike and I had the opportunity to both speak at in Minnesota earlier this year,
Mm-hmm.
and he was talking about his new book that's coming out November. Is that sort of the timeline? We're going to talk a little bit about the end.
Yeah, absolutely.
And and Mike was one of the first people I really saw going and looking at the evidence and talking about like all the things that are true that we know about today in this very changing world. And I don't know about all of you, but like in my world and working with our clients, there's a lot of unknowns right now.
Mm-hmm.
There's a lot of like, how is this going to change? What is the new marketing measures of how we see this is going to work? Who else do I need to be thinking of other than Google? And Mike, I really feel like your work, your research, your knowledge is helping us do our own grounding, ironically, in sort of evidence, things that we can control so that, today day around our goal of like preparing your content for AI search, that we can actually give tactics to say, hey, look, this is what the evidence say, this is where we go. And so, Mike, I think thank you for being able to give us that evidence for us to ground ourselves and sort of take control of like what we can actually influence and make happen as this world changes.
Yeah, absolutely. Like when I started my book, it's called The Science of SEO. I just gotten to this point where I was just like, I'm tired of saying it depends, right? Like my background is in computer science, and I'm like, okay, well, if I wanted to work at Google, what would I have to know in order to like be onboarded, be effective? And really that comes down to, information retrieval, natural language processing, and, at this point, more AI related things as well. And so I was like, cool, let me dig into all this stuff and understand what's going on. Because the reality is that Google's never going to be like, here's our algorithm, here's how it works. But what they do is share their innovations. Like they regularly are saying like, okay, we built this thing, you should check it out. And, there's been a lot of what they've been doing over the years in that move from lexical search to semantic search that they've shared a lot of information on that in the SEO community we don't know enough about. And so it's been really important to me to share that stuff so that we can all like understand, like you said, what the evidence is and move forward as a result of that.
Love it. So that's what we're going to do today. So we're going to get into this switch from lexical to semantic search. We're going to talk about how that's changing context in SGE and ChatGPT and the consumers of sort of this world. And then we're going to tie it into knowledge graphs, and I'll speak then about like schema markup and like what we can actually action today to kind of make this all make sense and take control. So let's go ahead and jump in. So over to you, Mike. Walk us through some of these key things.
Cool. So yeah, there's two primary search models. There's lexical search and there's semantic search. And so lexical search is very much about, counting words. Like where are these words that you're looking for targeted? And the next slide shows it a bit better as a visual. So as an example, in this case, we've got the keyword Daniel Radcliffe. And so in SEO, typically you're like, okay, let me use it in the page title. Let me use it in the URL. Let me put it in the body copy 30 times or whatever it is. And so historically, that is how Google has worked, like counting these words, looking at the relationships between those words and the links and so on and so forth. But semantic search is more about understanding what words mean. And so computers continue to get better at that. But effectively, it's able to say, okay, based on the semantic meaning of a query, like how rich is the actor who played Harry Potter, it can break that down into net worth and then figure out, okay, the actor that played Harry Potter is Daniel Radcliffe, and then use that information to come up with what the answer is. So Google made this shift a long time ago. Like, in fact, back in 2013, I believe it was, they rolled out something called Word2Vec, which basically converted words into vectors. And let me take a step back because that concept predates Google. Like that's how search engines work. And so effectively what's happening is these words are converted to coordinates in multidimensional vector space, as you can see here in this example. So effectively words are turned into numbers, plotted in space, and then they look to see the relationship between those words. So on the next slide, we show what we call this vector space model. So when you're looking to rank pages, what you do is you convert the query into a vector representation, and then you convert the documents into a vector representation. You plot them both, or you plot all of them into vector space, and then you perform an operation that's called cosine similarity to see which one is closest to the query, or which ones are closest to the query. And that's used as one of the primary measures to determine whether or not something should rank and how well it should rank for a given query. So when we talk about relevance in SEO, it's not just a qualitative factor that we say, okay, I look at this page, it seems like it's more relevant than this other page. It is a mathematical operation. And to that end, with everything being these coordinates in space and these angles between them and so on, you can do mathematical operations on words to determine the relevance. And so one of the famous examples, if you take the vector for the word king, you take the vector for the word man and subtract it from king, and you take the vector for the word woman and add it to the result of that first operation, you get the closest vector you get is for the word queen. And so this is something that holds up across vocabularies, across languages, and so on. So it allows us to turn this concept of relationship into a series of mathematical operations, particularly linear algebra.
I love the word relationship because we're going to talk a lot about that, right? Things in context, what's the relationship between words, relationship between entities. This is sort of, while you're bringing me back to my high school math and vector algebra, it really comes down to what is the relationship between things.
Yep.
And I think that's going to be a theme as we kind of talk through this, right?
Absolutely. And so when we think about relevance, again, it's cosine similarity. So when you've got something where the cosine is close to 1, that means it is a very close relationship. Whereas if it's a cosine that's closer to 0, that means it's orthogonal or not related. And if you have it where it's -1, that means it's opposite. And so these are the measures that are used by a variety of different information retrieval solutions, some NLP solutions as well, when you're looking at the similarity of text. And so again, it's just a mathematical operation. It's not like someone's looking at a page and saying, oh, this is more relevant. And to that point, again, no SEO tools are really doing things like this. And so it's really important that if you want to get a sense of what's really going on, that you leverage tools that can do things like this. And there's plenty of data science tools out there that allow you to do stuff like this. And so one of the reasons that Google has gotten so much better is because by using neural networks and transformer technology, they're able to create these vector embeddings or vector representations that are more dense than they were before. So when you go back to when information retrieval started, you're really just looking for the presence of words, right? Like, is this word here or is it not? And so that could be like a 1 or a 0 for each word in a given query. Whereas now you have these very dense or robust values that are representing every word, every sentence, every document. And so those relationships have gotten a lot more complex, a lot more sophisticated, and a lot more accurate. So when you talk about transformers, the T in GPT for Chat GPT, that's been a giant leap forward for natural language processing in general, but specifically for Google, it's made them a lot better at understanding, what's related to other things.
Mike, are some of the now, and I want to just touch on, you're talking about GPT, Google's gotten really better at it, but it's the same technology. AI a lot of those AI capabilities. So whether that be what Amazon's doing, someone else is developing their own AI, they all have to look and understand this idea of vectors in order to. I'm seeing nods.
Yeah, absolutely. You broke up for a bit. Sorry. Yeah, but absolutely. So this concept of these vectors is used across most things in search engines, and well beyond that, like all sorts of machine learning tasks are leveraging vectors. And so that's why I'm saying it's so important for us to understand it when it comes to SEO. Now, even entities have vector representations, right? So at the end of the day, everything that we're doing here, we're converting words or concepts into numbers and then using it for those different mathematical operations. And so, I just want to highlight this, that it's not just like, oh, well, we took a paragraph and we turned it into numbers. It's everything. They have website vector representations, they have author vector representations, and all this stuff is used as signals in Google's algorithms across the board. So, excuse me. So when you think about this, it just goes to show how important it is that we take more comprehensive looks at content rather than just making very narrowly focused pieces. I think in SEO, it's been such a tactic to say, okay, let's just go to the long tail. Let's make a 500-word article about this very specific query and then keep doing it over and over until you've got coverage across everything. And we all know that longer tail keywords are less competitive, so it's just easier for you to move the needle with that approach. But ever since Google introduced dense vectors, they've been able to better understand content. There was something that they highlighted a few years ago they called, I think it was passage ranking or passage retrieval, where they're
Yep.
able to select very specific components from a longer piece of content and then surface that, even though the piece of content was about a variety of things. So to that point, Google is just getting, or search engines in general, not just Google, because Bing was one of the first ones to do it. They're getting to this point where they're leveraging language models to be a key driver of how they can surface information in the search engines. And so one of the things that's arising from this is this idea of conversational search, where it's like you have your initial query, then you might want to do follow-up questions. And so that just makes what we call context window just a lot more specific.
And these are fun, right? Because you can then use like other words to be like, well, my co-founder used to be like, how old is Mark? And then like, where did he go to school? And like, you can kind of carry on sort of that chain of thought, right? As you go through.
Exactly. And so in SGE, which is Google's specific version of this, three things I want to highlight. One, the queries are able to be much longer than the Orwellian newspeak that we're used to. So historically, a query could only be 32 words. Now it can be, I don't know if there's a published limit yet, but they can understand better what it is you're saying in your query. One, because they're able to extract the entities from it and then use the relationships between them to surface things. But two, because they can understand a bigger context window using a language model, they're just able to take in more input to then consider what the output is. And then you've got the AI snapshot, which is basically kind of like the featured snippet on steroids, right? Wherein you have this block of text where they're explaining whatever the answer to the question is. And then you've also got a series of the sites that they have cited for this. And then you can click into that bear claw area in the upper right, and then you can see all the things that were referenced. And then newer versions have implicit sites, or not implicit, they have inline citations where you can click on it to say, okay, this paragraph came from this page and whatever. And then after that, in that third position, you've got that conversational mode. So then the user can ask those follow-up questions. So this whole concept is called retrieval augmented generation. It's a fancy way of saying, I have a language model, let me feed it results from my search engine to pre-tune it to then give you that answer. And so, it's used for question and answer generation. It's used for fact verification. It's used for generating, additional questions based on that as well. And so Google has their own version of this. It's called Realm. I can't remember exactly what it stands for. Yes, Retrieval Augmented Language Model Pre-training. And so same sort of idea. You perform a query, it runs it through its neural retriever, and then it says, okay, here's a list of documents that are related to this. Take all the text from these documents and then feed that into this text knowledge encoder, and then it'll give us an answer that then can be that AI snapshot or feature snippet or whatever use case that they're using it for. And this is also the technology or the concept that underpins BARD as well, although we all know BARD is nowhere near as good as ChatGPT. And so when we start to talk about knowledge graphs, there is a lot of synergy between knowledge graphs and large language models. So, the situation is that, of course, knowledge graphs are really good at being factual, whereas, large language models are not. They're prone to hallucination, and, things will just like go off the rails, especially the longer the output becomes. But there are three different models for how you can use knowledge graphs and LLMs together. So one is called the knowledge graph enhanced large language model. And so the inputs or the data inputs from the graph are used in the pre-training and also in the inference stage, meaning when it's giving you the output. Whereas you also have the large language model augmented knowledge graph, where you're basically allowing the large language model to do all the reasoning and then create the text, but it's using the knowledge graph data explicitly. It's like limit what you say to what's in this knowledge graph. And then you've got the synergized large language models and knowledge graphs, where it's like it's one system just working together, and they feed back and forth between each other to then generate the content. So a lot of value in understanding and leveraging, creating, building your own knowledge graph in this world, because it's the best way to get more precise content and output that you're actually going to be able to use.
That whole grounding piece, right?
Mm-hmm.
And we also have a really good article that's just dropped by Gracia around, how you can actually like think of your schema markup building that knowledge graph that you can then use for like all these different types of integrations with your LLM and how that comes together. And that's like really sort of what brings us to some of the SEO pieces. Why don't you talk a little bit more about RAG, and then we'll jump into like, okay, well, what about this knowledge graph, and how can I do something about it?
Yeah, absolutely. So if you've ever used the live crawling feature in ChatGPT, you're doing retrieval augmented generation, because effectively you're saying like, hey, find this thing in Bing, bring it back to the language model, use that to give me a response. And a lot of people are doing this in a variety of ways, whether it's, if you're using AIPRM, we have a lot live crawling functionality. Lots of tools are leveraging this. But there are also people that are explicitly doing the same thing using knowledge graphs. And so again, when we talk about the value of this, if you've got your own knowledge graph set up that you can then plug into these language models, it allows you to generate, or like you said, ground your copy that's generated in facts rather than whatever it was trained on that may be, wrong or not relevant to you or your business.
Yeah, and in our conversations with a lot of our enterprise clients who are, say like trying to reduce the risk that comes from AI, especially as they try to build their own internal large language model,
Mm-hmm.
they're asking us about like, hey, well, what is it about the knowledge graph that I can use to help kind of track and kind of make that happen?
Yeah, absolutely.
So let's touch on a couple of these, and then we'll kind of get into that content.
Sure, absolutely. So, as far as where we're going in SEO, our rank tracking is going to get a lot more complex. One, we need to figure out like what is position one at this point. Is it what's in the AI snapshot, or is it what's below there? And then the other thing is that rank tracking will be more difficult because of the fact that it requires us to render the entire page to then get all the information out. And then context windows are going to make the results more personalized, right? Like, because your subsequent search in that conversational mode is going to further limit the options that are going to be chosen from in order to generate what that response is. And so you got to think of it as like effectively you're creating these user journeys or these search journeys, and they're all branching out in different ways. And so you've got to answer all those questions in your content. Otherwise, you're going to fall out of the result set pretty quickly.
Which is why that breadth is so important, right? You
Mm-hmm.
can't just like do that one piece.
Right, but the thing is, these follow up questions are not the same as what you get and the people also ask. So again, we're gonna have to figure out how do we extract this content so that we can use it to inform what we're doing. Because right now, again, the rank tracking solutions aren't set up for it, and we don't know what this is going to look like when it actually rolls out, because obviously SGE is currently in beta.
Yeah, it's sort of that whole metrics of like how things are going to like be measured in success are totally changing, right?
Absolutely, absolutely. And so another thing to know is that Google has moved away from keyword matching to this concept of neural matching. And so you're seeing a lot of instances where you'll have a query where the entity is not mentioned explicitly, but Google is able to match it with the right document because of its understanding in those relationships in the knowledge graph that they've built.
Oh man, entities, understanding context in the knowledge graph. Booyah.
And the last thing I want to highlight is this idea of fact verification. So historically, Google has said that they don't do it. They felt like they don't need to be the arbiter of facts. But I think as a reality for the wealth of content that's going to be generated using large language models, they're going to have to use it as a way to separate the high quality stuff, or the helpful content, as they say, from the stuff that is low quality. And so there's a lot of precedents for this, like Amazon, Facebook, all these different organizations have leveraged knowledge graphs in this way. I would be shocked if Google wasn't already or isn't considering it very soon.
Amazing. So many questions. I want to sort of like, I always like to kind of like slow down to speed up,
Mm-hmm.
right? So thank you, Mike. Like you've given us all these like data points, I sometimes like to go back to basics to explain like some of these key, I'll say concepts that we need to, these key entities that we need to understand in order to kind of connect those dots. And so I'm going to take us through some definitions and then some examples. We're going to talk a little bit more about knowledge graphs, and then we'll wrap up with some key things that you can action. So one of the words that Mike was just talking about was entities, right? So it's like a thing with specific attributes. And I know that's super generic, but it is, right? Like how are we describing different things? And one of the key concepts that we want to talk about, especially as SEOs, is that you can be the heroes and you can be sort of the definers of those entities, and that entity home lives on your web page. The entity home where you define that lives on your webpage, right? So when we're talking about building that really breadth of content, we're talking about sort of defining that with a lot of clarity sort of on your page, because we want you to actually be the entity authority, right? So in order to kind of show up in this new search, to show up in this new world, you want to make sure that your vector, right, is positive and sort of like says yes, this is indeed the authority.
Mm-hmm.
And so some things to keep on kind of thinking about is, again, you want to own that authority, right? So while you will define it, you might relate to third parties. You don't want a third party defining that for you. You also want to make sure that you're connecting it with regards to how that entity, how that thing, right, relates to other things. And don't worry, I'm going to give you an example so we can start talking about just things and entities. That, like, the definition lives on that primary page that talks about it. And I've often talked about this in schema markup, is like you don't want 12 different pages talking about that same topic. You want to relate them, right? You want to bring that context. And that the power, or the thing that's so exciting, is that there is this comprehensive vocabulary called schema markup that we can use to describe these entities, right? And good news, the vocabulary was also defined by all these search engines, these people, including Bing, right? Bing, Microsoft, was actually part of that initial definition all those years back.
Mm-hmm.
The other piece I think that we think about, and it's a different way of explaining, like what you talked about earlier, like this change from lexical to semantic search, we can also think about this as like an entity maturity scale, right? So where historically, like we played in that keyword, sort of that kind of lower kind of maturity piece, we then sort of talk about topics, which is like groups of keywords. We've been doing that for a long time. And now we've, like, over the last couple of years, started talking about entities. And entities are, again, what relates topics with context. Do you see how we're using the same words, Mike?
Yep.
You and I are talking the
Yep.
same thing, right? And so when you can define things and link them, then you can start linking those entities, that one page, with other authorities, right, off page, right? So you can say, oh, this is tied or is the same as this entity in the Google Knowledge Graph or in Wikipedia or in Wikidata. But the gold standard is if you actually have all of the entities linked in your own knowledge
Mm-hmm.
graph, where embedded in context in those is also linked to those external sources. And so this is what I'm excited about, because Schema App, like we sort of built Schema App with the gold standard in mind. Like that's actually how we've, as a semantic technology company, like how we've always thought about doing things. Now it is the harder way, and means that like you have to sort of like be comprehensive in sort of how the content has the things that you need to relate, and that you can use the vocabulary. But we've really built that platform that allows you to define entities, each with their uniform resource identifier, that you can link them all using context of the vocabulary, and that we actually even also use some of that natural language processing. So if we want to automatically at scale define things that are known in other authoritative sources like Wikidata and Google's Knowledge Graph, and I'm sure other kind of in future, right, as we define that can all be done at scale, sort of, in a semantic way. Um, and so schema markup really helps you build these knowledge graphs, which is actually preparing you for this semantic search. Pause. Like exciting, right?
That's where you're supposed to like drop all the confetti and everyone goes crazy.
All
Yeah.
right, woo! Like booyah, yeah. Like it's like when we started this back in 2014, we had this vision, right? And like the time is now. Everyone else gets it. It's not just those of us that have been sort of living in this world for so long. So it's really exciting, and I think the most exciting is those of you that are in the SEO marketing space who've invested in schema markup and doing it the hard way, right? Like really making sure that relationships and asking how content needs to evolve, which you're doing because you're here
Mm-hmm.
today. Like you're already on that journey to semantic search. And what is semantics? I'm going to do a couple more definitions. Like semantics is a term to study of language and meaning. And so you can talk about this as like defining relationships. And so when you talk about semantic technology, which I've just reiterated again, like Schema App is a semantic technology company, it's about sort of using technology and tools to articulate the meaning and relationships between things. Wait a second, Mike, you were just talking about this, right? We're talking about like how the future of AI search is about like defining meaning. And so schema markup, historically, if you've seen me present, I said that was the language of search engines. Well, guess what? It's also the language to define the entities on your website. We do not need, like, this is not new.
Mm-hmm.
It's just a new way of framing it now that we have this new context. Now that we have this new reality that AI search like is here and that it's accelerating. And Google and Bing have been giving us hints, right? So like these are quotes over the last 8 months where Ryan Levering, the staff engineer who's responsible for structured data at Google, responded on Mastodon with like, over time, richer, correct semantics will favor more connected graphs. Like half the world didn't even understand what he was talking about, right? What he was saying is we're going in this direction, talking about like the neural networks, the semantics that Mike's just like educated us about.
Yeah.
And in fact, Fabrice Cannell also is talking about it.
Yeah, I think, what they're saying without saying it is like use more, give us more
Yeah, do
structured
it.
markup. And I think a mistake that a lot of people make is like, okay, I'm not going to mark that up because it doesn't give me a SERP feature. I think we should be marking up
Yep.
everything because they're clearly looking for this in a variety of ways. They wouldn't define a whole vocabulary and then not use it. So, the more that we can give them, I suspect the more they're going to be able to extract features and then rank you for everything that you're talking about on your pages.
I know. And that's the shift, right? Like I have a slide here. I think it's the next one. Like from rich results, right? Which is what we were targeting primarily to like optimization for understanding. And just so everyone remembers, like the vocabulary was created in
Mm-hmm.
2011. This is not new, right? How we were using it and why it's urgent and important is now new, right?
Mm-hmm.
Because if we can build this knowledge graph, if we can use a standard vocabulary, by the way, it's schema.org, to explain those references, like we're winning. And I just like to illustrate some of you that might like where graphics are easier. Like this is one of our enterprise customers' knowledge graphs. This is like all the entities or all the dots. You can see all the lines that connect them. You can see often they're connected in different ways. And so when you use semantic schema markup, you're building that marketing knowledge graph, like that marketing data layer, which as we move into this sort of AI kind of data-driven world is so important. And it's about sort of connecting entities and about sort of, really ensuring that they're, truly expressed in triples. And the properties are expressed in what's called RDF, and RDF are an expression of triples. And so, Michael, you and I get excited when we talk about triples, but like triples is like the foundational element of a knowledge graph. Tell us a little bit about it, sort of, Mike, in your words.
Yeah, absolutely. So RDF triples or semantic triples are this concept that, it's like a subject, predicate, and an object. So if I say something like, Martha is awesome, that is a triple. Like you're explaining a thing and a feature of the thing or the attribute of the thing. And so as I say that, if you're visualizing what schema markup looks like, that's what it is, right? Like each thing is like, image objects. Here's the image name, here's the file name, or here's a different feature of it and what have you. And so my whole point here is that this can also be extracted from text. It's the sort of thing that Google is able to see at web scale. And if they see facts, they can then extract and then put it in a structured way. So it's not just the schema markup, but it is, it's best to provide the schema markup because that's a more explicit way, whereas this is more implicit. And so when you think about what a knowledge graph is, it's really just networks of triples, right? So like in this example, you've got the Mona Lisa, which is the thing, and it says was created by Leonardo da Vinci. So that is the triple, Mona Lisa is the subject, was created by is the predicate, and then the object is Leonardo da Vinci. So in that case, you see how those are continued to be connected because obviously Leonardo da Vinci did a lot of other things than just the Mona Lisa, and then that creates a whole big graph of things and their attributes.
Yeah, and all those properties for everything, every class or type that you're describing on your pages, right, are describing those triples, which then define the entity. It's like its own little graph,
Mm-hmm.
which, by the way, we use Schema Markup to introduce ourselves because we're dorks here. We love this stuff. And it's also like you talked about how it's a control point. So I think like in this world where like AI is like, like trying to understand and infer things, whether you do it for grounding or just as like, this is our brand's marketing knowledge graph that we can actually be like, say, this is our control point. I love that sort of idea that you can use it because I feel like a lot of people are feeling like, the world or like the world is changing so fast,
Of
right?
course.
Which is why we have to like go back to basics. And so when you build your knowledge graph, right, you using Schema Markup, you can connect everything, you can help AI search understand it, and then you can also use it to train it. So I want to make sure that we sort of go through an example, and then we'll open it up. If you have key questions, why don't we put those in the chat now? We have about 10 minutes left, and I have about like 3 minutes that I'll give you sort of an example. Um, we're moving from rich results, right, which is what SEOs were driven with Schema Markup to really think about Schema Markup to build that knowledge graph, right, to prepare your content and your sites for AI search. And so there's really three things like for preparing your content that we wanted to make sure you highlight. So one is, I think, Mike, to your point earlier, sort of it's that breadth piece, right?
Mm-hmm.
Which is like, you can't just like go after the keywords anymore. You can't just mention it, but you have to be like really talking about breadth within the content. Seeing nods, we're good. Okay. The second is like be thorough with your schema markup and explaining what that content means and how things are related. And not just like within like authoritative sources, which is like step 3 here, but also amongst itself, right? Like how is the content contextually related to another? Mike, you brought up that like that second part of the SG experience textual searches,
Mm-hmm.
right? So like there's follow up to that initial question of which your content piece, if it's got the breadth and the connectedness and the context, can be that source of truth for it, right? And then like finally across the site. And I love the example because it's a simple one. It's a physician page, but it really helps you understand how content architecture plays into this. So, like, what are the things that in schema.org, Bing, Google, Yandex defined that they wanted to know about a physician, right? Like, this is sort of the source of truth as to what vocabulary, what their machine about it. And then how you kind of design your content to talk about those things, right? And then ideally, also, as you do this, you're also thinking about like, well, where am I defining the available service on my website? And ideally, you're then linking to it. And so when you're graph, it's not just explaining the parent organization, but it's saying here's the URL where that entity is defined,
Mm-hmm.
right? And pulling in all the context about what that entity is. Or you can actually sort of articulate sort of more kind of interesting things about sort of even a simple concept like a rating, right? What are the different concepts within that? Again, we're just adding context, right? To understand what those numbers on that page mean. And then finally, like I love nesting external links. So this one was describing plastic surgery on Wikidata. I love Wikidata because it's not language dependent. It's sort of just like that. Like this is the node, this is the page that describes that entity as in all different languages. But again, also a URL where like where does this information live on the site? So if the machine, right, if AI want to go and learn more, that knows where that entity lives and exists. And so these are things you can do today,
Yep.
right? These are the things that frankly like we do with our every day, all day, because we're constantly saying, how does your content need to evolve to understand more context? So those would be like the three things that we recommend as you prepare your content.
Yeah, definitely. I mean, I feel like, there's some opportunities that I'm not even using right now. And I just want to like go to the AIPRM site and just mark it up everywhere for all the things because it's just so valuable to that end.
Yeah, and so and that's like that's again like the what are the initiatives we're doing, right, to make it happen? Like you and I are both sort of in this world right now, enabling you to help build those knowledge graphs or understand content
Mm-hmm.
themes that or understanding sort of like tools and things that you can do in order to understand key topics. So let's go ahead. There are a couple of resources here, Mike, that your team's put together. Do you want to speak to those, and then we'll jump into
Yeah,
questions?
absolutely. So we've got, just a state of generative AI report that we do quarterly just to show people how things are progressing. We've also got a few blog posts that I've written on the concept of content relevance. So, these ideas that I kind of sparked this conversation with. And we've got a lot of other things on the AIPRM site as well. I don't know how much we've shared here, but there's a lot that we're doing around this space so that people can understand the integrations of like knowledge graphs, generative AI, things like that.
Amazing. And on the same time on Schema App, we're also talking a lot about how you can take control and take action to build your knowledge graph. We especially are good at complex architectures and mid to large enterprise. That's sort of our play of where we're really good. And then working sort of with you to understand like how else you can, evolve your content on your page, your content architecture in order to get the best. So you can kind of get in touch with us, reach out. Also, you can sign up for our newsletter where you'll get sort of other kind of content and sort of initiatives like this. All right, we're going to go to questions. All right, let's go have a look. There's some good ones in here. There's one really, really early on I wanted to go back and look at that someone else said that they had it around product. So just scrolling here. We've noticed that branded search for products does not seem to include the manufacturer's pages in the SGE output. For example, when I search iPhone 13, none of the web pages citations are from Apple. They're all citations are third parties. How do brands get their pages in the generative content?
Yeah, I think that is a hard question because it's still evolving. And what I've seen is exactly what's being described here. This idea that, Google's trying to have the third parties weigh in on these things. And so you would anticipate, like typically a branded search, yes, you want your brand to be in it, but they're not doing that right now. Right now, they are kind of erring on the side of showing more different perspectives than showing the brand itself. And there's not much you can do there, but the thing you would do would be everything that we're discussing here, like marking up everything so that you're surfacing that stuff, your own knowledge graph for them to pull from. But right now, they're just not prioritizing that content.
Yeah, and I see this as like an evolution of where we saw more long tail pieces. Like I would say, like category pages over the years have also sort of dropped off
Mm-hmm.
as being like more generic to like the very specific query. This it's different but similar, sort of in that vein of sort of how things are going.
Mm-hmm.
Dan is asking us a little bit, how do we create a visual representation of a client's knowledge graph? So the one we shared is actually out of our systems or out of Schema App that allows you, once you sort of like create that to display it. So if you are a Schema App customer and work with one of our customer success managers, just raise your hand and they will make sure that you know how to find that. There are other free tools out there that sort of will crawl your site and show those. And so like, my God, the names are often like, there's one that comes to mind, but it's escaping me. Do you remember the name of the guy who has like the one kind of one visualization tool?
And links.
No, it wasn't InLinks. It was another one. InLinks does a different visualization of it, right?
Yeah, but there's open
Um,
source tools that do this as well. Like graph
yeah,
graph theory is like pretty prevalent in the whole Python world.
a lot across the world, right?
Or like
Yeah.
Gephi, which is a free tool that's more like a user interface for it, where you would upload the data and then it can visualize it for you.
I think that's the one I was thinking of. Yeah.
But Schema App is the
We
easiest
do.
way to do it.
Yeah, yeah. If it's like, well, it depends on the scale too, right? Like if you're just looking at a small site, but again, ours is sort of built out of our ontology software, which is like where all those triples are stored,
Hmm.
right? All right, we got time for one more. Because schema markup can be a bigger lift than just publishing content, how do you recommend getting client buy-in? Oh, this is my favorite one, and this is evolving, right? So when I talk about like we're working and we're living in a world where the measures are changing,
Hmm.
right? So historically, like we put together that use case, and we can still show lift right now based on rich results. We can also show lift based on adding
Hmm.
semantics. And so I think that's like what you'll start seeing. Our latest case study that we're just finishing drafting is talking about like how do you actually measure the value of adding semantic schema markup. And so we're big believers when we engage with our clients. We don't have to cover everything, although these days that seems to be the right thing to do to prepare. But you can start small, kind of measure, kind of put together that ROI, and then go ahead and scale it across the board. But if you go to Schema App and go to our case studies, there's ample examples with regards to specific rich results, and then you'll start seeing us articulating ones around semantic search as well. Show them this webinar. Like part of it's like, are you going to wait to see hard evidence, or are you going to future proof yourself for this
Yeah, I
change?
think a lot of people are just getting or coming around to the idea like, hey, we're using large language models, why not do this, right? Because they're like, we can use this as an input for what we're doing here. So I think there's a lot more appetite for it than there was before. But the other thing is exactly what you said, like just do a small test, show the value, and then
Yeah.
expand from there.
Yeah, and I always like to start with like what's most business critical. Like if your organization has like, a core is that they have to grow or that they're betting on for whether it be Q4 of this year or into next year, like that's where you start, right?
Mm-hmm.
Like, you start with the things that are most important. And again, that's sort of like part of how we engage with our clients to ensure that like we're focused on the right things, right? And
Absolutely.
then it'll evolve from there.
Absolutely.
We're at time. I wanted to make just give you the last minute. Tell us a little bit about this book that you're writing.
Yeah. So the science of SEO, it's all these subjects and much more. I'm really digging into patents and research papers and all the cutting edge stuff that's happening with information retrieval, natural language processing, so on and so forth, so that we can get an understanding of like, how does modern search actually work? And it's probably the most comprehensive source in one place to learn all the things. Not only do I give you the overview of all the theory, I also show you how to build a search engine as well. So check it out.
Amazing. Thanks so much for your time today, everybody. And get Mike's book, learn more about this, and we look forward to your phone call to talk about building your marketing knowledge graph.
Cool. Thanks for having me.
All right, happy day.